All right.
All right. So, hello. We have 3 out of the 4 people who submitted their FRQs. Um, Let me actually make the
Wait, only four
permissions.
people submitted?
Yep.
Yes,
Only four
dead
people
serious.
submitted
Only
FRQs.
4 people submitted, and several of you guys stayed for like the majority of the time, and then just dipped, and we never heard anything back. So,
I mean, really, we're not we're not grading anything. We're not. It's not like you need to turn in for a grade or something like that. But all you're doing by not doing the FRQ and turning it in us is shooting yourself in the foot. Because let me put it this way: the average points on the FRQ is 12 points total. The average is like 4.6 total.
that was
Oh,
the national average in
That is the
2019.
national average for that question, and we took that question. That was
damn.
from our AP test.
Damn.
Yeah.
So, here, just before we get into the question, and I don't know if everyone here was, I don't know if Neil, for example, was here when we did it, but like, um, in my opinion, right, we only give you the question for 30 minutes, specifically 30 minutes, and we're doing that in the middle of the tutoring session in the thought that like you were planning on being here for 30 minutes anyway, so there should be literally no reason why you shouldn't be able to do it. I get it if we were just like to post it there and be like, yeah, do it by next meeting. No one would do it because that's just homework. I get that. I feel that. But we do it at the end of the last 30 minutes of the tutoring session because we figure you're going to be there anyway, so just do it. It literally can't take more than 30 minutes. That's it.
Yeah, the AP's
So
recommended time is 25 or
So
20 even actually.
it's just a rant on the fact that out of like 9 to 10 people that we had that day, only 4 people submitted. I mean, you do what you want. We're not gonna hunt you down for it, but just I can promise you the people who consistently do them will do better on the tests,
And I
on the
can
AP
promise
test.
you that if you do not get a 4 or a 5, the FRQs will be the reason why.
What was the average score for the people who did submit?
If we take out the outlier, it was pretty close to that 4.6. Because there was
Which
one
is
score who was an
Wait, what's a
outlier.
good score?
The thing is with FRQs, it really kind of depends. What percent do you need to get a 5? Isn't it like 60% or
I'd have to look
something?
through the numbers. But so what I'll say is, no one on this FRQ got below a 4 on the one that we did here.
Mhm.
Which for the first FRQ, not just for physics, but apparently for all of AP, I'm personally happy with. Like that's pretty good because most people's first FRQ is like a 1 to a 3. So that's good. By the end of this, we'd want you to be around, 7 to or above at least. But this was literally the first FRQ, not just for physics, for everything. So please don't feel bad if you got lower scores. And I will unlock the links in a minute. I did send the links, I believe, to everyone already. They were just locked.
Wait, was the outlier a good outlier or a bad outlier?
It was a good outlier.
Like what? Super high or super low? Ooh, super high.
It was a 4 points above the next highest score.
All right, I'm going to unlock them now, so you can look at them.
And I will say, of the 4 people we had take the test, 2 people made the same very very simple mistake, which which will be the first thing we talk about.
Okay, so again, don't be discouraged by your scores. I am happy with everyone's because no one got below a 4.
Yeah,
That
everyone
that
got
was
above
that was
average.
great. That was great. Everyone got pretty much at the national average or above for the entire year of physics. So I'm happy with that, and as we keep practicing, we will get better. So I'm just gonna dive into the biggest one that people made mistakes on, and I don't know if O'Connor drilled this into you like she did
No,
to
they
us, but
didn't. They didn't have O'Connor.
oh, they didn't have O'Connor. Okay,
That's
well,
why. That's why it's not drilled into their head.
so whenever you're doing an FRQ, what you need to do is read the question like several times. Like really, really, really read the question. Because if you did, you would have noticed this small, tiny little phrase right here. There is negligible friction between block A and the tabletop.
And so half the
Oh
people
god.
who took it did notice, but half the people didn't.
So, anyway, obviously, if you took one of the sorry, let me start with this. One of the things with FRQs is, and it kind of sucks, is that like if you miss details like that, and you use that on the rest of your answers, because that's how FRQs are designed, is for you to use them on the rest of your answers. You kind of get points off for every single question or every single part of the FRQ because every single part of the FRQ builds on the last one, and if you get the first parts wrong or the fundamental parts wrong, then the rest ones just can't be right. So that's why it's super important to really read and understand what the question is saying. If you were one of the people who did use friction in your answers, do not feel bad. That's why we're practicing, okay? But if your answers, for the people who did pick that, in my opinion, your scores probably could have been doubled because from what you wrote, it seemed like you understood the concept in general, but because you used friction, it kind of threw it in a different direction. So from what we read, and I think Alan agrees, that a lot of your guys' scores could have probably been doubled if we read through the friction part. So just make sure we read and reread the question, especially if you get to the end. Just double check that everything is correct.
And also, I feel like Mr. Florence has kind of drilled into you guys that you always need to be considering friction. For AP, if there is friction, they will state it. If there is not friction, they will state it. If it's not stated, there's probably no friction. Because that's just, or if it's not stated, it is irrelevant. Because AP is very specific about that stuff, and for the most part, you're not going to see friction in your questions.
Okay. Are there any questions about just that so far? Also, can everyone verify that your links did unlock and you can see what you got?
Yeah, I can see it.
Okay. Okay, so suppose that the mass of block A is much greater than the mass of block B. Estimate the magnitude of acceleration of the blocks after release. Pretty much everyone got this. Actually, everyone did get this. There was, I think, one answer that we were like on the fence of, but everyone got the point for correct answer, which was actually what I'm going to do. Am I able to pull up the answer key?
Can you put the PDF for the mark scheme in here?
Let me see. Let me see if it's going to let me. It might not because the one I use for Discord is the projector account. Yes, it looks like it is going to let me.
All right, nice.
Oh, okay. All right, here it is. Here it is. All right, so you had to put something like 0, small, negligible, much less than G, anything like that was correct. So one thing I want to, when you're stating your answers, especially for estimation, try to use as little words as possible. Some people put like relatively somewhat close to 0. If you were to put something like that, I think a regular AP grader may not have given it to you. So
or if you put like relative, like don't use the word relatively. Just say what you think it is, because if as the more fluff you add, the more they may think that you don't really know what you're talking about. And you're trying to make it as vague as possible.
Okay. So correct answers for here was anything that was similar to just 0, right? And then explanation, you pretty much just had to say, so you had to just relate it to mass, right? You just had to say block B was heavier, and you could either talk about inertia, or you could just talk about Newton's laws. Anything like that would work. The main thing that people got points off for, as stated before, was friction. A lot of people said, well, there's more friction on block A on the table. And that's not, the reason why that's not the reason is, so if mass of block A, I'm just going to come up. So first of all, obviously we said there's little friction. That's in the question. But imagine that this was like on ice, for example, and there's like no friction. The force from block B, the force that block B is putting on the system, is what? Where does that force come from? Can anyone tell me?
Gravity.
Yes. So if it has a really small mass, which it is the thing in this problem, then its force is really small. And if that tiny force is trying to push a boulder, for example, it's going to do nothing, right? Even if that boulder is on ice or a really frictionless surface, it's a boulder. You're not going to push a boulder with your pinky, right? So that's what you have to think of here. Block B is applying a really small force because it has a really small mass, and block A has a much larger mass, so it's pretty much going to do nothing. So if you didn't use friction, you pretty much got it right. The only people who got points off was for using friction. Are there any questions about this part?
Yeah, I have a question.
Mhm.
So essentially, we would just say that the mass of block B was too small to actually move block A.
Correct. Like if you look at their example right here, their example was close to 0 because block B is so light it can hardly budge block A. That would have been a valid answer.
All right, next.
Okay. So I'm not going to write everything because you can kind of see the answer key. So there, we did that part. All right. Now part 2, no one got. So don't feel bad about not getting this. No one got this one. But let's look at it knowing what we got for part 1, let's look at it again. Again, imagine everything's frictionless, right? Imagine the mass of block A is so small it's practically non-existent, right? What is the force on the system? Again, it's the same. Should be the same as last time. Where's the force on the system coming from?
Gravity.
Gravity on what specifically?
Copy.
Yep. And if now, just for a second, imagine that the rest of the system didn't exist. Imagine that block B was the only thing here and it was just falling. What would its acceleration be?
5.8 meters per second.
Yep.
Or
Yep. And then imagine that we tie to that block A that has almost no mass. What would its acceleration still almost be?
same thing.
Yeah, 9.8. So for part 2, you had to put, it's on the next page. You had to put anything, you had to put G, 9.8, 10, anything like that would have worked. Actually, everyone pretty much just put it would be larger, which, and this is, again, why we're going over this. You have to sort of think about where the problem is trying to get you towards. So in this case, it's trying to get you to understand that the only force acting on the system is from block B. And if block A is pretty much non-existent, then the acceleration is going to be, since it's only acting on block B, it's just going to be 9.8. And then their examples of reasoning was just because block B is almost in free fall, or there's negligible mass and tension, anything like that. Are there any questions so far about part A overall? Okay. So part B was a free body diagram question. And so I'm pretty sure everyone got the tension forces, if I remember correctly, right, Alan?
Yeah, everyone got the tension forces right.
Yeah. And everyone got the normal forces, the normal force on block A as well, I'm pretty sure.
I think there was one exception, but
Okay, yeah, so most people got the normal force on block A. The most common errors were, well, the most common error by far was putting friction on it, which got you 1 point off. And then the second most common error was not drawing the free body diagram correctly. So remember, whenever we're doing free body diagrams, and you put a dot, right? And it says this in the question as well. Every force has to be represented by a distinct arrow starting on and pointing away from the dot. So, for example, if you were talking about the tension force, you can't do this. That doesn't work. You have to start it from the dot and go outward. Like this. There weren't really any other issues with this one, right, Alan?
it was just that people didn't print it out, so like they didn't label the dots, and I mean really it wouldn't matter because you would have the dots to label, but like if for future reference, if you're doing an FRQ, make sure to write whatever they give you for the problem exactly as it appears on the sheet, because then it's the most, if you're not gonna print it out, because then it's the most similar to what your experience should be like if you're doing it on the test.
And that was more important later on. Like there's a question later on that said, like you're supposed to put a checkbox next to yes or no, and we had people just like completely ignore that and go straight for the explanation. And it was the people who specifically like wrote it on a separate sheet of notebook paper. People who printed it out just checked it correctly. So if you're going to write on notebook paper, try and lay it out really close to how it's laid out on the question, because we didn't know what to do for those people that just flat out didn't answer, like when it asked you to check yes or no, which is some of the later questions. Are there any? Go
Just
ahead.
a question about labeling.
Mhm.
Do we have to write like F of G, or can we like write out the?
Yeah, so if you look at their examples, for example, the normal force, anything N, F of N, normal force, F of table, table force, or any other label indicating the force is normal or comes from the table. So if you look at that description, you can sort of see there's a lot of leeway, as long as it's clear that it's the normal force in one way or another.
Like for a really safe way to do it, if you're using notation that's not specifically straight from your formula sheet, you could like physically write out for the variables. You could say this is defined as this. So like if you're
Yeah.
going to, for example, if you were doing, I think I'll talk more about it later when you actually have the one we have to derive the equation. because it's a better time to talk
Mhm.
about it.
Yeah, if you're ever concerned about labeling, just write it
Okay.
out. Because, like, for example, for the second point here, we talks about gravity. It said gravity or grav force was acceptable, but if you wrote capital G or lowercase g, that would have been wrong.
Because that's
So,
representing either the constant or like 9.8 meters per second, which aren't
yeah.
forces.
So if you're ever concerned about labeling, just write out the words. But for the most part, any things that make sense are valid.
Yo, I have a question.
Hmm.
So like, okay, so like I get like, 'cause if I think about it in my head, how since there's like negligible friction, uh uh the block wouldn't move,
Hmm.
would move like very little,
Yep.
with the other with a smaller mass on block B. But the thing is, how would I like explain that? Because if I think about it, like that's the only force in the x direction, so I just can't like figure out like how I would actually like figure that out. You know what I mean? Because
I mean,
it's still the only force in the x direction.
yeah, because the thing is, for them, like if you look at their responses, their two examples were because block A has a large inertia, it won't speed up much, and because block B is so light, they can hardly budge block A. Like you don't need to articulate it like an essay, you just need to show understanding.
So
All
like,
right.
yeah. I mean, the easiest way, like I said, is to look at their answers, and especially if you look at their second answer, which is the one I would personally put. It's probably a lot less complicated than you think they wanted. They're like again, if you look at my screen, you should be able to see it, but close to zero because block B is so light they can hardly nudge block A. Like, that's all you had to put. You just had to articulate that it was because the mass that was doing the force was so small that it couldn't do anything. That's all you pretty much had to say.
All right. Thank you.
Hmm. Does anyone else have any questions about part A and part B so far?
Wait, so part B, all you had to do was just draw the forces and stuff, or just label the forces of the
You just
lines?
had to draw it.
You
Yeah.
had to draw
Did
and label
you?
the forces.
Who's talking by the way? I can't see names.
This is the hill, the
Okay.
guru face.
Yeah. Did you do the FRQ or I don't? No. Did you? I don't think so. Anyway, but this is what they were given originally. It was just two dots, so you had to draw the forces and label them.
Mhm.
Okay. Any other questions so far?
Well, how do you know the forces are other than? Is it from part A that you figure out?
Yes, they're all. It's all FRQs are all like this, where they build off of the previous parts. So you had to look at this. The key ones, and I'll draw it on here just so you can see. The key ones was that there was a normal force here, there was a tension force here, there was a tension force here, and there was a gravity force here.
So the problem was essentially just to figure out whether you can draw a free body diagram. Okay.
It was and that you can identify forces without extraneous forces. Like I said, the
Okay.
most common mistake was just the friction thing. Second most common just being not being drawing the diagram right, but that's a very easy fix.
Oh, and also with your free body diagrams, if they ever don't give you the dots, you need to remember that for AP, the only kind of like valid free body diagram is just a dot representing a point particle. You don't draw like a 2D object. It's just a dot.
Although I'm pretty sure they'll always just give you the dot, but
Yeah,
I mean,
probably.
in the event that they don't,
Yeah.
always just draw a dot. All right, so derive an equation. So there were two ways to do it, as you can see. You had a primary solution and a secondary solution. Do you think? I don't know if anyone's going to be able to answer this, but do you think it's going to be more helpful to go from it through it from the answer key, or do you want me to show you how you would derive it if you were just on the test? If anyone has any opinions. No. Okay.
Well, the thing is, I think most points someone got in this, I think was 2 points. I don't think anyone got all three, and I think a lot of people got 1 point because they just put
No,
no
I
answer
think
keys.
one person got all three. I remember that.
Oh, okay.
But here I'll just go over it from scratch.
Yeah, I think the easiest way to do it.
Okay. So what you had to do. Let me go back to my tablet. Sorry. Oops. All right. So what you had to do was first think about systems, right? So the net force on the system is going to be equal to the acceleration of the system times the whole mass of the system. But the force net on the system is coming from just block B, right? So the F net is equal to the mass of block B times gravity. And then you would say that the mass of block B times gravity, or actually I'm going to keep it as G, is equal to the acceleration of the system times the mass of the system, which is the mass of block A plus the mass of block B. And then from there, you would solve for the acceleration of the system by saying it would be, it would be G, I'm just reversing the order of these two here, G times the mass of block B over the mass of block A plus the mass of block B. And that would be is equal to the acceleration of the system, or just A. And that's what they have down here. Is equal to the mass of block B times G over mass of block A plus mass of block B. Does anyone have any questions about how you derived that equation and how you get to that point? Okay, does anyone have any questions about anything they did, or just questions overall? Please, if you have any questions, please ask. This is the time to ask. Okay. If you have any questions later, feel free to ask. Okay, so consider the scenario, blah, 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 blah. About, and it just asks, does the equation agree with what you said for part AII? And AII was where it said you had to say that it would go approximately the speed of the acceleration due to gravity. The key thing to this is you didn't actually have to say yes for you to get it right. As long as you were truthful on your yes or no answer, you got 1 point. Or actually, no, you didn't. Sorry, my bad. But you didn't actually have to answer yes. Your reasoning just had to be valid. But what you basically had to see. So remember that part AII was saying that the mass of block B is super heavy, and the mass of block A is like nothing, right? So if you look at this equation, if the mass of block B is something, we'll just say 1, then that's over times G over 1 plus something that pretty much doesn't exist, so 0, right? So that it becomes 1 over 1 times G, which if it doesn't matter if I chose 1 or not, it's going to be divided by pretty much the same number. That ends up being 1, and then it just times G. So as the mass of block B increases and the mass of block A decreases, A becomes pretty much not relevant in the equation because it's so small, and so it just becomes the mass of block B over the mass of block B times G. And that just ends up being 1 times G, or G.
And I actually remember specifically for this problem, I had a really hard time getting the equation for part C. So when I ended up driving the wrong equation. So when I got to part D, I realized, well, if I say yes, I won't be able to provide valid reasoning. Like it won't match up. So I basically said, well, I have to say the wrong answer but provide the right reasoning, and ended up getting the point for it.
So like if you look at their example, you're allowed to say no. If you got part AII wrong, and you recognize that by this point, or not necessarily you got it wrong, just you recognize that they're different, you could say no, and you could still get it right, as long as you explain that according to the equation, A becomes less relevant, and it just becomes 1 times G. So there, you can go ahead and read through their examples, but it pretty much just says when mass of A is much less than mass of B, it can be neglected in the equation derived in part C. So does anyone have any questions, about this and just pretty much how A becomes not relevant? Mass of block A. All right, any questions on the FRQ so far at all? right, can everyone just say something so I know that you're alive and not sleeping?
Alive.
Yo, what's up?
All right, cool. Just wanted to check. All right, and Alan, do you have anything else to say on that one?
No, that's it for me.
Okay. Part E was probably the hardest one, because it required thinking. Also, again, same thing about paper. I had, well, she's not here, so I'm allowed to call her out. Ellie did not put her answer for it. So like, if you're gonna write it on paper, make sure you like write out this part, or at least make it very clear which option you put, because otherwise, we don't know what you're doing. So yeah. So the correct answer was the tension 2 is greater than tension 1. And there were a couple different ways to explain it. But pretty much what you had to see was this. If I'm going to scroll all the way back up for a second. Actually, I'm going to go to this one. This one. All right. So what you had to sort of see, if I can zoom in a little bit. So in the initial problem, and I think, Alan, because I can't go back to it right now, does it ask about when the, or just asks about general? Never mind, it just asks about general, right? Okay, so let's imagine that they are just random masses, right? If this block falls, block B falls, and it pulls block A, and this mass, and this is pretty much massless, right? There is no energy loss to the pulley because it's massless, it just kind of exists and doesn't do anything. So all of the force from block B goes into moving block B and block A. Whereas if the pulley has mass, like it suggests in the last part, then the force of block B has to go not only into pulling block B and block A, but also to rotating the pulley. So because of that, because there's some energy, and this is also the unit we're going to go into next, energy. So if you didn't get this one right, we're going to be talking a lot more about that. But since when the pulley has mass, some of the energy created by, or not created, but you know, that's put on block B into moving block A has to also now be used to rotate the pulley. The system as a whole has to move slower because not all the force is being used to move the system. It's now being used to rotate the pulley. And the last part of that is if you know that the acceleration of block B is less. So remember, block B, if we were to draw a free body diagram, has the force of gravity, or the weight force over here, pulling down. And that doesn't change just because the pulley has mass. So if the system as a whole doesn't accelerate as fast, then block B has to have some force counteracting that, which is, of course, the tension. And so therefore, the tension has to be greater if the pulley has mass, because if the pulley has mass, the system accelerates slower. And if it accelerates slower, then block B has to have a counteracting force that is greater than when it was accelerating faster. So if we scroll all the way back down, and again, this one was the hardest one on here. And also, just in general, by the way, FRQs always get harder as you go on. So the first questions should generally be the easiest, and the last ones are generally the hardest. It's the same for IB. I know I don't have any IB people in here, but same thing. They get harder. So if you didn't get it right, don't feel bad. But this is basically what it is. You just had to recognize that the rotating mass caused a lower acceleration, and a lower acceleration means that the block B has to have a counteracting force.
But you
That's
could
the
still
force
get 1
like-
point even if you got the answer wrong. As long as you realize, as long as you reasoned that, well, if this force is greater than this force, it means the acceleration must be changed in this way. Like for the reasoning, they have the examples there, concluding that a small acceleration implies that t2 is greater than t1. Then if you were to put, the wrong answer but still put that down, then you get the right answer. You'd still get 1 point.
So even if, as long as you related acceleration to your answer, you got the point. Even if you weren't actually right in your answer or in what happens to acceleration. You could have said acceleration was smaller, unchanged, or larger, and you would still get the point.
As long
But
as
in order to get both
your
points,
answer.
in order to get both points, though, you had to be completely correct. You had to say that the acceleration was less and T2 was greater than T1. And I'll scroll out so you can see the second half of the explanation. That is not me. All right, whatever. There we go. Okay, are there any questions about anything on the FRQ? or if you have questions about your particular score. If you have questions that for some reason you don't want to ask because it's personal to what you got, you can always feel free to message us. But if it can benefit everyone, please ask now. Does anyone have any questions about the FRQ as a whole, or just what they got, or their answers, or anything like that?
You sent the scoring guidelines in like the notes/resources, or no?
Yes, I can. I can put it there. So, wait, where is it? There it is.
And then for the future, we'd like to see more people actually do the FRQ.
Nice,
Because,
that would be
I mean,
nice.
it doesn't really matter to us. It's not like we're taking the test. But if you are taking the test, the FRQs will be the reason that your score is lower. Because, as I said, the average for this question was a 4 out of 12. So, most people do good on the multiple choice and then lose a whole bunch of points in the FRQs.
So, and one other thing, let me just double check this. But yeah. So the FRQs on the test, just so you know, there are 5 questions. It used to be 6, but because of the hold, I took out the units. There's now only 5. There is 1 qualitative/quantitative translation, which is 1 question. There is 1 paragraph argument. There are 2 short answer questions and 1 experimental design. This one was a qualitative/quantitative translation question. So if that gives you an idea of where we are. I can tell you the hardest ones are probably the experimental design question. The other ones are not that bad, and this one isn't that bad. And again, all of you got a 4 or above, which again is at the national average for people who have taken the entire course, which you guys haven't yet. So I'm perfectly fine with that. If anyone wants to say, how did they feel about this when they were taking it, or how do they feel about it now? Anything along those lines? I'm just curious what everyone's thoughts are.
Not gonna lie, I thought I was gonna get a 0.
Well, you didn't, so that's
But
good.
yay.
Did they curve the test rate?
From what I remember, AP does it by they give the physics test out to some college students, and then they say like the lowest 20% are 1, lowest to mid is another 20, and they take the 5, 4, 3, 2, 1, and assign that based on the 20% groups. And for physics, I think, I mean, not to scare you guys or anything, but for physics, I don't know if it's still the truth, but it used to have the lowest pass rate of any AP exam, and I think that was taken by Lang. But I don't know where it is now. But it's one of the lower ones. It is not high. So.
But you guys can all do it. We believe in you. Now, to answer the question specifically about curving, no, not really, because once they make the mark bands, and this score gets you this grade, those don't change, and you will know those probably about a week before the test. They will put them online. Those will not change. Like even if everyone bombs the test, they're not going to change it. And the reason why is because the way that they get those numbers, like Alan said, is by giving them to college students. And they basically say, all right, the average college student gets this grade, so that grade will be a 3. And then
The average college student who's taking physics 1 in college.
Yes. And then a certain higher percentage of that got this grade, so that's a 4. And above that is a 5. So that's why they don't change it, because if they've given it to college students already, and they've established that the average student taking physics 1 in college can get this score. So that's what we're establishing as a 3. And again, you will know what those are. They change every test, but you'll know what they are about a week to 2 weeks in advance.
Okay, sounds good.
Okay. So our plan for the most part is to do FRQs at the end of every unit. As we go on, the FRQs are going to be like this one was pretty much just dynamics. A lot of FRQs are very few FRQs are like this. Most FRQs incorporate stuff from multiple units, especially ones like experimental design and paragraph argument, usually taken stuff from multiple areas. And quite frankly, also qualitative, quantitative. We picked this one because it really only did one area, which was, tension and dynamics. But as we keep doing this, you guys will get better. It will get easier, and it'll be good. Anyway, we were going to do energy today, but I also hear you guys have a camp test. So Alan, I don't know what you want to do.
Well, if they have a camp test, I guarantee you they kind of want to prepare for that, or at least use the whatever remaining higher brain function they have on the camp test. So therefore, maybe we should
Right.
start energy Thursday.
What was someone said something I couldn't hear you. What'd you say?
We also need time to cry.
I mean that
yeah.
that's valid. That's valid.
What?
That's part of preparation for the camp test. Don't worry.
Alan, why would you cry when you can spend that time studying? Don't be so silly.
So these people, do they want for the paragraph thing? Do they want like long responses or concise and just answer though?
We'll do paragraph responses and you'll see. I can't. It's hard to explain without actually doing one. But like when I say paragraph response, they're gonna give you like 3 or 4 things that you have to talk about.
Mhm.
It's pretty guided. Like there's
Right.
not a whole lot of ways to go wrong with it. But you just have to understand the concepts.
Yeah.
But don't worry, we're gonna go over all the different types. The types we're gonna go over most are going to be the experimental design, qualitative, quantitative, and paragraph argument. We were not going to do very many short answers, and the reason is because like if you can do those 3, then you can do short answers. So.
Okay.
But yeah, I think you guys probably want to study for camp. Last thing I'm going to say, like I said, is especially since we only got a couple of people submit it this last time. When we do this, just do it. It literally only takes 30 minutes. It is not very long, and you were going to be here anyway. Just do it. You'll get better at the test if you do it. I promise. But I mean, if you just don't, if you just hate FRQs or just doing work, then I guess that's on you. I don't know. It was just sad that not very many people did it. So please do it in the future. Alan, do you have anything else to say?
No, that's it for me.
All right. Well, now it's time for you all to cry.
And that's time for me to cry, man. I gotta do my bio AA.
Well, you're really gonna cry then.
Yeah, not fun. Image processing.
All right. When you upload this, just cut out the last part.
Wow.
All right.
I can maybe do that.
So yeah, that.